Alright, the first question is about Tom Smith, and in this question, the TS1 is really asking the opposite of utilization. Basically, I want to find out what amount of time he's not working. Okay. Well, to do that, first we got to calculate the utilization. Utilization is, well, there are many ways to think about utilization. One way you can think is demand over capacity. Right. In this case, demand over capacity is a slightly easier way to think of it. So demand over capacity is, well, think about this. A call arrives every 3 minutes, right? Call arrives every 3 minutes, which means there is a demand of 20 calls per hour, right? Similarly, he can finish one call in 2 minutes. That means he has the capacity to finish 30 calls per hour on average. Well, you can think of it that way. So in that case, demand is 20 calls per hour, and the capacity is 30 calls per hour, making this 2/3 or 0.67. Another way to think about this is slightly similar, but not, is capacity is utilization, not capacity. Utilization is P divided by M. Again, mostly this formula makes much more sense when there are multiple workers, but it works when there is one worker too anyway. So processing time is 2 minutes, right? It takes him 2 minutes to process one call. Inter-arrival time, the call arrives every 3 minutes, so it's 3, and there's only one worker, so same idea, right? Doesn't matter how you think about it. All right, after you have found the utilization is 67%, what can you do? Okay, let's change the color here. What can you do is, well, think about this. In 8-hour shift, he's utilized 2/3 of the time, right? That is, he is busy 8 times 2/3. He's busy 8 over 2/3, which comes out to be 16 times 3, right? So 16 divided by 3. 16 divided by 3 is 5.33. Well, in 8-hour period, he is busy 5.33 hours. That means he is free 8 minus 5.33, which is same as saying 2.67 hours. In 2.67 hours, there is 2.67 times 60 minutes, which is same as 160 minutes, right? So given that he has 160 minutes available to read, and he can read 1 page per minute, he can read 160 pages. You could have done this slightly quicker. You could have said, well, if he's utilized 2/3 of the time, he is not utilized 1/3 of the time. That means 1/3 of that 8 hour, you'll get 2.67, and you multiply by that 60 minute in an hour, you get 160. So 160 pages. You can do either way, same thing. Okay. All right. The next question is, how long does a customer have to wait on average before talking to Tom? Now, this is the real TQ problem. Well, TQ, given that there's only one server, you can use the easier formula. TQ equals to 2. Oh, well, let me write the formula first. TQ equals to P times U1 minus U times CVA square plus CVP square divided by 2. Okay, your processing time is 2 minutes times your utilization is 67% divided by 1 minus 67 is 0.33 times CVA. Well, CVA is, if you look at up, you will see the activity, the activity time is 2 minutes, and the standard deviation of the activity is 1 minute. So your CVP is 0.5. Your inter-arrival time is, standard deviation is also 3, arrival is also, the inter-arrival time is also 3, so 1 square divided by 2. Okay. You can solve this. So this is 2 really, because it's 2/3 divided by 1/3. So 2 times 2 times 1 square, 0.5 square, so this is 1.5 square is 0.25, so this is this comes out to be 2.5 minutes. That means on average you expect to wait 2.5 minutes. All right. Let's look at the next problem. So this was the extra credit problem. This was rather, it sounds very difficult to find what would be the cost of telephone call, because think what is happening. If there is, if there is this telephone wait line here, this is virtual queue, suppose. So this is, suppose this person is online, this person is online, and he is online talking. Then one line, so this is Tom, he's talking to this person on phone, this person is also on hold, this person is also on hold, this person is also on hold. It sounds very difficult, right, to find your phone cost, because you have to pay for the phone, this phone line, this is being used, this phone line which is on hold, that is being used, this phone line that is on hold, that's unused. Well, it's hard to think about it. But if you think of it slightly opposite way, remember, you know that the calls arrive at the rate of 20 calls per hour. Right? The calls arrive at the rate of 20 calls per hour. You also know there are 8 hours. So you know altogether you're receiving 120 calls, 160 calls every day, right? 160 calls every day. You also know each call has to wait for 2.5 minutes on average. You also know on average a call lasts 2 minutes. So that means when somebody makes a call, your phone line is on use for 4.5 minutes on average. Doesn't matter which one, how many at any given time waiting, doesn't really matter. At any given time, any given call, 4.5 minutes of your telephone line's time is used. 2 minutes he's also talking, 2.5 minutes you're really only waiting. So you use altogether 160 calls times 4.5 minutes, right? Comes out to be about 720 minutes, which is same as saying divide by 60, same as saying 12 hours. So in each shift, 12 hours of talk time or telephone lines time is being used. You pay $5 per hour, so you pay $60. Now this might sound counterintuitive, right? How do you use 12 hours of telephone time even though you only are open 8 hours? Because at some point 2 lines might be used, right? So altogether, or sometimes you could be doing nothing too. There is no telephone line being used too. So altogether 12 hours of use and $5 per hour is $60. That was an easy problem, right? All right, this question is it tricked quite a few people, but think about this. There are 5 independent development centers. It's like having 5 servers. Okay, a call on average, this company receives a patent every 7 months. It's like, say, there are 5 servers. Think of this development center as 5 servers. And there's a queue. There's a queue of here. Each of this queue is a patent. Let me make slightly red ones here. So there's projects to be worked on. Okay, this is the queue. This arrive at the rate of 1 every 7 months. Okay, 7 months. Inter-arrival time is 7 months. Okay, standard deviation of 7. So making CVA equals to 1. Well, it takes 28 months So it takes 28 months, no matter this. So suppose this guy gets this, this guy gets this guy gets this, and this guy gets this, so forth. If it goes here, it takes 28 months. Again, CVP also 1 because the CVP is 2 because the processing standard deviation is 56. So processing time is standard deviation is 56 and the mean is 28, so CVP is 2. Okay, the first thing we have to find is utilization. Well, utilization, easiest way to do here is P over M. Your processing time is 28 months. Your inter-arrival time is 7 months, and you have 5 servers, so making it 80%. Okay. How long does it take on average? Again, it's an easy TQ problem. Again, the interesting part is the int is wait plus processing, but let's find the wait part first. Well, TQ is P by M times U power 2M plus 1 minus 1 minus U times CVA square plus CVP square divided by 2. Okay, processing time, it's easy to find, right? It's usually given pretty straightforward. M is 5. Your utilization you just calculated was 80%, 0.8 root 2. M is 5 plus 1 minus 1 minus 0.8 is 0.2. CVA we calculated was 1 plus CVP was 2, so squared divided by 2. Alright, it's pretty easy. This part, it just comes out to be 5.6. This is 0.8 square root of 2. 5 times 1 is 6, so 12 minus 1 square divided 0.2 equals to power multiplication 1 plus 4 divided by 2. Alright, 5.6 times 0.8 square root of 12 is a little bit more than 3.3. It's 3.46 minus 1 0.2 times 5 divided by 2 equals to 5.6 times 0.8. 2.46 minus 1, 3.46 minus 1 is 2.46. This whole thing divided by 0.2 times 2.5. So this comes out to be about 40.439 months. And depending on how you round it up, this number might be slightly different. Okay. All right. Now what do you have? Well, we calculated the wait time, right? The wait time was 40.439. But the question asked the total time it goes from receiving the patent to be launched. So it waited. Now it has to be processed, which is, we know, 28 months. So it comes out to be 40.439 plus 28 is 68.439 months. Okay. All right. The next question is, how many products does Mango have in pipeline? So this is really, this confused quite a few people, but this is really a little slow problem. I equals to RT. Okay. And you can you can do this problem two ways really. You can first figure out how many items are in the queue first, or you can think of this in the queue part and this processing part as the whole process. If you think of this as the whole process, to go from here to come out of here, it takes 68.439. If you think of this as a process, this is the whole thing. If you want to find the inventory from here to here, okay, in that case, inventory is what you want to find. The product is entered in the system at the rate of 1 every 7 months, right? 1 every 7 months. So rate is just the inverse of it is coming at the rate of 1/7 per month, right? Rate is expressed in terms of flow unit divided by time unit. So if you take that time here is from to enter here to come out here, it takes 68.439. This comes out to be 9.77. You could have done it slightly different way. You could have thought of this queue as a system. If you think queue as a system, then the time to traverse this queue is only 40.439, right? How many items are in this queue? Inventory is RT. Again, everything is same. It's going at the rate of 1/7 times 40.439. 40.439. So that's how much is in the queue. But how many are being served? Well, it's utilized 0.8% of the time, and there are 5. So at any given time, you expect to on average find 0.8 times 5, that is 4 units being worked on. So this should come out to be about 5.77. Thus, 5.77 patents waiting and 4 patents being worked on. You have 9.77 patents altogether in the pipeline.